Okay, section 5.5. Close to being done. One more after this, we'll be ready for lots of review and then your test. So, here's the thing about this section. In fact, I've noticed it about a couple of sections now. They'll give you just one or two things, and then they give you lots of problems on them, which I only give you a couple on. And then they move on to one more section with one or two things, and it's getting to where it's not a whole great big heap of stuff anymore every time. So we may be starting to phase out some of the highlighting videos. So basic ones currently that are really important are the ones that I'm going to be writing. And as long as you have the highlight videos, I know you're getting them all. So I'm only going to be writing the ones that are like super applicable to what we're doing. Doesn't mean you don't need the other ones. Like I said, it could be that they come back a little bit later. For example, this one shores up something that we did 2 sections ago. So 2 sections ago, I remember telling you, wait a second, and we'll get to that one to prove that it was actually a right triangle. Well, this is that thing that proves it now. So they come back around. It happens. It comes back. So for this one, they say that if 2 sides of a triangle are unequal, then the opposite angles are also going to be unequal. Just like when you have 2 sides of a triangle that are congruent, the opposite angles are congruent. The opposite is also true. It also means that, and this is the one that's so super important, the larger side is across from the larger angle, which means the middle side is across from the middle angle and the smallest side is across from the smallest angle. That's a piece of useful information. The one about the 90 degrees thing is this one. A perpendicular is the shortest distance from a point to a line. Now, there are lots of lines that I could draw from this point to this line. I could give you that one right there. I could give you that one right there. I could give you this one right here. But the one that's going to end up being the shortest is the one that drops down directly to that line, which is always going to be the perpendicular. That's always going to be the shortest. Okay. Not excruciatingly useful in the homework yet. Will be so super useful in the homework later. Today, before you ever get to your classwork, because you have classwork separate from this, I have 3 triangles set up. I gave you some information about it: 80 degrees, 20 degrees, 50 degrees, 90 degrees, 50 degrees, 150 degrees. Gave you some information, labeled it all out. I would like to know what the longest side of each triangle is, the shortest side of each triangle, and what kind of triangle it is: isosceles, scalene, or equilateral. Take a few seconds, try it. Pause it, let's see how you do. Okay, so in order to do these, you're first going to have to figure out what the other angle is. So this one happens to be missing 80 degrees there, which makes that one isosceles. But we'll get back to that in a minute. This one happens to have currently in it 140 degrees, so this must be 40 degrees missing. This one has a 50 here and 150 there. So I could say that since these two are a linear pair, that one is 30 degrees, which means this one must be 100 degrees. Or I could have said that these two have to add up to 150, so that must be 100 degrees. But now that we've got them all out, I can start answering these. So my longest side up here is going to be these 2 sides because they're across from the largest angles. So here is a trick question. It's side AC and side BC. Here, my longest side is side EF. And here, my longest side is side IJ. Now I wanted to know shortest side, and that's an orange. Up here, my shortest side is going to be AB. Here, my shortest side is BE. And here, my shortest side is HI. And then I wanted to know what kind of triangle it was. Well, I went ahead and told you that this one was isosceles. This one is a right triangle because it has a right angle in it. This one is obtuse and scalene. Technically, this one is acute scalene, to be technical. This one is a right triangle, but it is also a scalene right triangle, because none of my sides are going to be the same. You can't have an isosceles right triangle. You cannot have an equilateral right triangle because it can't be equiangular. Okay, so there is that, which leads us to the classwork and homework, which is located on page 197. Don't worry, it's not much. Classwork is number 3, 7, and 11. Homework is numbers 1, 5, 9, and 13. Simple, easy peasy, piece of cake. No problem. See you for the last one.